Scatter plots and lines of fit. All right, as always, we're going to start here with the state standards, just a few standards that are being covered today. Also, your success criteria, what you need to learn by the end of the lesson. You need to be able to read and interpret scatter plots. You need to be able to identify correlations between data, and you need to be able to write and interpret an equation of a line of fit. Again, remember these success criteria, these sentences here come directly from being able to meet the state standards. So this is what we consider very important to do. All right. Some vocabulary that you need to know. Scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. Correlation is a relationship between data sets. You can use a scatter plot to describe the correlation between data. And your line of fit is a line drawn on a scatter plot that is close to most of the data points. All right, so talking about correlation, you can see in the graphs here, you can see this is a positive linear correlation. So if you look at these, the scatter plot, you can see all of these points trend upward. So the points lie close to a line as x increases. This is x. As x increases, y also increases. So what that means is that you could draw a line and it's going to look like it will have a positive slope for a linear equation. This one goes down like a negative slope. So that means as x increases, your y decreases. So that is a negative linear correlation. Just think about the slope when you're talking about positive or negative. And this one has no correlation at all. That means the points have no pattern. They're not close to anything. There is no single line that you could draw anywhere that would represent that data set. All right, also key idea over here, using a line of fit to model data. Here's 4 steps that you need to be familiar with in order to use a scatter plot to draw a line and make an equation from that line. Example 1, interpreting a scatter plot. All right, the scatter plot shows the amount x in grams of sugar and the number y of calories in 10 smoothies. All right, so you have the graph here. It has smoothies across the top. You've got calories on your y-axis, and you've got grams of sugar on your x-axis. So let's see if we can interpret what the data means. All right, so A part says, how many calories are in the smoothie that contains 56 grams of sugar? All right, sugar's across the bottom. So you can use your pencil to kind of trace, and it says 56 grams. So here's 54 and 58, so that we know that 56 would be in the middle. So if you trace that line up, you're going to see there's one point here, and it is 270 calories. So 56 grams of sugar has 270 calories. And that can be written as an ordered pair because you know you would always have your x and then your y. All right, B part says how many grams of sugar are in the smoothie that contains 320 calories. Okay, so now they're giving us our y number. So 320, go up to 320. There is one data point there. You come down, and it's going to be 70 grams of sugar. All right, so 70 is your x. 70 grams of sugar is 320 calories. All right, now it says, what tends to happen to the number of calories as the number of grams of sugar increase? All right, as your x increases, it looks like the y is increasing as well. So as you add more sugar to these smoothies, the number of calories increases. So that's what's going to happen. All right, the self-assessment I want you to pause the video, take a few minutes, and see if you can answer these questions from the graph provided. All right, hopefully you took time to do the self-assessment. It says, from the graph, find the number of smoothies for each description. Explain your reasoning. All right, find the number of smoothies. All right, find the number of smoothies with at least 270 calories. All right, so if you come up here to calories, at least means it includes this one. So you're going to have 1. And then everything above 270. So at least means 270 or more. So 1, 2, 3, 4, 5, 6. So 6 smoothies contain at least 270 calories. All right, find the number of smoothies with less than 50 grams of sugar. All right, here's the grams of sugar. Here's 50. And if you look up through here, there are none in this area. There's no smoothies below 50. So that means there's 0 smoothies with less than 50 grams of sugar. All right, C part says find the number of smoothies with more than 275 calories and less than 62 grams of sugar. Okay, so this says and. That means it has to be both. It has to be more than 275 calories and less than 62 grams of sugar. So if we come up here and see more than 275 calories, that would be right in here. More than 275 calories and less than 62 grams of sugar. Here's 62 grams of sugar. So it's going to be right here. Those two are going to be the only two that are above 275. Wait a minute, hold on. Above 275 and less than 62 grams. So it's right here. So those two are above 275. They're above this line, but yet they're below this line. Sorry, my line's not very straight. But anyways, those two are the only 2 smoothies that meet both of those restrictions. Example 2, identifying correlations. Describe the relationship between the data in each scattered plot. All right, so for A part, we have age and vehicles owned. So on the vertical axis, on your y-axis, it says the number of vehicles owned. And across the x-axis, person's age in years. If you look at this, this looks like a scattered plot with no correlation. All right? No correlation means that a person's age or the number of vehicles does not depend on a person's age. So the scattered plot would have no correlation. All right, B part says temperature and coat sales at a store. All right, so you can see on the y-axis, we've got coats sold per day. And on the bottom, on the x-axis, we have average daily temperature. You can see here the temperature goes from 35 to 70, and coats sold tend to go down. So you can see it has a negative correlation. It has a negative linear correlation. You could draw a line that represented this data, and it would have a negative slope. So what that tells us as the daily temperature increases, less coats are sold. Example 3, finding a line of fit. The table shows the total number Y in millions of subscribers to a video sharing website X years since 2010. Write an equation that models the total number of subscribers as a function of the number of years since 2010. Interpret the slope and the y-intercept of the line of fit. All right, so an easy way to do this, you can take 2 points. You can determine if it has a slope. You can graph these points and look at the scatter plot and then use the 2 points to write an equation. You also can use your calculator if you know how, okay? So what I'm going to do is show you how to go through the steps to do this. So you go click on Stat and Edit, and you can enter your list of points. I've already done that to save a little time, but enter your X in L1, enter your Y's in L2. Then if you do second quit, that is saved in your calculator. That table is there. Now I want to look at the points. So let's turn on my scatter plot. So second Y turns on my scatter plot. So I'm going to hit enter. Right now it's off. I'm going to click enter again and click on, and you can see it's lit up with the little dots here. So that is my scatter plot. I'm pulling from list 1 and list 2. It's going to show it as little squares on my graph, and it's going to be in blue. So that all works for me. So I'm just going to hit enter and second quit. And now I can go to my graph. So if I go graph, I can see one dot here. Now, why do I only see one dot? Well, this goes from 10 to 10, and I think this one's going up to 20. But if I want to see all of these, my X's, I have to have positive X's out to 8, which I do. But I also have to have my Y's have to go up past 89. So let's go to Window. And I'm going to change my Y positive number. My Y max has to go up to at least 90. And let's change the Y minimum. We don't need that, so we're just going to change it to a small number like -2. All right, so now you can see these, the scatter plot or the points from your table. So this is your scatter plot. Now, once your scatter plot is in here, you can also have your calculator write an equation for you. So go back to Stat. This time, instead of editing, this time we don't need to put the table in there. We need to calculate an equation. So we're working with a linear equation, y equals mx plus b. Here it uses ax plus b, but your linear equation, so click 4. And it's going to give you your A and your B. So you could write that equation. Y equals, you could round that to 10 maybe. Y equals 10x plus 7. Okay? This R shows you your correlation is very strong. The closer it is to 1, the stronger it is to a exact correlation, meaning the line represents the points very well in this equation. So let's go ahead and write this down. So y equals 10x plus 7. And that's an equation that represents this data. Okay? So now it says to write an equation that models the total number of subscribers as a function of the number of years since 2010. And then it says interpret the slope and the y-intercept of the line. All right, so the slope is 10 and the y-intercept is 7. So in 2010, there were about 7 million subscribers, and the number of subscribers increased every year by 10 million. So that's what these numbers here represent. All right. If you have any questions, please let me know.